Okay, as we continue working with our quadratic equations, what we're going to talk about now is solving these quadratic equations. And in solving a quadratic equation, we are going to be working with what is going to be called the roots of the equation or the zeros of a function. And what we're finding is we're going to have four things that are used interchangeably. We're going to have solutions, we are going to have zeros, we are going to have roots, and we are going to have x-intercepts. Now, all four of these things are used interchangeably for one another. It depends on the material, it depends on the question, but as we work through them, we're going to find out as we solve a quadratic equation, that is the same thing as finding a zero. That is also considered the root, or it will look as the x-intercepts. So just keep that in mind as we're going and we work with these things. And that's why I have the Frere model here, where we have those as our Frere model because they all represent the same thing, and need to get used to that. Vocabulary can sometimes be a limitation, and we want to make sure that we know when they say one of those what they're talking about. So as we start to solve by graphing, what is the solution of this equation? And we're going to be solving those equations right there. And in one here, it says x equals 1, x squared minus 1 equals 0. So what I've done is I've gone and I've isolated my variable, so I use my inverse operations to get 1 to the other side. So I have x squared equals 1, and in order to get rid of that x squared, I'm going to find the square root of that. So if I find the square root of one side, I must find the square root of the other, and then I end up with x is going to be equal to the square root of 1, which could be either a positive 1 or a negative 1, because negative 1 times negative 1 gives me 1, and positive 1 times positive 1 gives me 1. So my solutions, or my x-intercepts, turn out to be negative 1 and 1. So if they're x-intercepts, I know that the value of y there is going to be 0. So what I'm able to do is I'm able to graph those points right here. And then I'm also able to look at my function and say that, realize that my y-intercept is my c value, which happens to be plus negative 1, which we have worked on. And then I'm just going to go ahead and graph those 3 points with a smooth line. I've also calculated this value up here, but at this point it's not necessary. But if I were to input 2 into my function, f of 2 equals 2 squared minus 1, which is going to be 3. So there you have it. That is the value of 3. So that's how I'm able to find those 2 points. So we're starting with a solution. So what does that 0 mean? Well, normally we would have y equals x squared minus 1. Well, what we're doing is we're solving for y equals 0. So when y equals 0 on the coordinate plane, when y equals 0, that is going to be the axis, and then there is going to be my solution. So that's how we end up with this y equals 0 over here. When y is 0, x became negative 1 and 1. So as we move on to this next example, we have x squared equals 0. Well, in order to get rid of, get x by itself, I'm going to have to find the square root of x squared. And if I find the square root of one side, I must find the square root of the other. So the square root of x squared is going to be x, and the square root of 0 is just 0. So we have a solution of 0. So let's see, when I go to graph that. Okay, so when I go to graph that, when x equals 0, so that ordered pair should be y equals 0, x equals 0. That's going to be my x-intercepts, or my roots. And when I go to graph that, I end up with, right there, x equals 0, y equals 0. And now I need to go ahead and plug in, and it turns out that this, of course, is my parent function. And when I do my table, I would find out that when I have, of course, 0 equals 0, but when x is 1, y is 1, and when x is 2, y is 4. And then I'm able to go ahead and graph those points. And of course, I can do my symmetric points. which we have been working on. And then when I go to connect those with a smooth curve, I end up with my parabola, and that is going to be x squared. And of course, we've done the function notation to know how to do inputs of x to get out y values. Let's see here. So going on to the next equation. Okay, so as we go ahead and do our information here, we have x squared plus 1 equals 0. And then if I do my inverse operations, I get x squared equals -1. And, well, if I find the square root of x squared, I have to find the square root of the other side, which is going to be the square root of -1. So x is going to be equal to the square root of -1, which for this course in Algebra 1, this has no value to us. That is going to be an imaginary number, and you won't learn about that until Algebra 2. But we are focused only on real numbers, and if you think about it, the square root, I'm looking for a number times itself that will give me -1. And there is no number times itself that will give me a negative number, because if I have a negative times a negative, it would give me a positive number. And if I have a positive times a positive, it would give me a negative number. So that's why this is an imaginary number, because there's no real number that will satisfy this condition. So I have nothing to graph, and I am done. We'll just call and done, because there's no way I can solve that. And we can continue on with these. And looking at D, I've gone and done my inverse operations here. I have isolated my x by moving my 16 over to the other side. I found the square root of both sides, and then x is going to be equal to the positive square root of x and the negative square root of x. So those points, remember, are going to be written as 0, -4, and 0, 4 right here. Those are going to be my 2 points. And of course, looking at my y-intercept should be -16. And then I use those 3 points to go ahead and just graph my quadratic. So just doing a little bit of simple math. So let's see here, this next equation. Going ahead to isolate, we're going to move our 6 over to the other side. And I'm going to have 3x squared equals -6. And then divide both sides, because I need to isolate that variable. And x squared is going to be equal to -2. And again, this is the same thing as C. The square root of x squared is equal to the square root of -2, and then x is equal to the square root of -2. Well, again, not a real solution. I'm not able to graph that at this point in time. So there's no real solutions, so we're going to be done with that one. And if we put that in the calculator, it's going to tell you error. So let's see here. Moving on to this next one. I'm going to go ahead and combine like terms, isolate my variable. So I add 25 to both sides. And I end up with x squared equals 0. And we just did this one a second ago. That's right there. X squared equals 0. So we have x is going to be square root of x squared, and square root of 0 is going to be x equals 0. Graphing this should be easy enough. It's my parent function. I have 1, 2, and when you go to graph that, you know that here we go. When x is 0, y is 0, so we have 0, 0. And then when I go ahead and do my ordered pairs, I have 0, 1, 2, and that is going to be 0, 1, 4. So those are going to be my points. And then, of course, my symmetric points. And connect them with a smooth parabola. And there you go. We've graphed those solutions after finding them. So as we move on to our next examples, let's see here. It's saying solve using square roots. What is the solution of each equation? Okay, well, that's actually what we were just doing. So let's pause for a moment. That's actually what we've been doing, but it doesn't ask us to graph, so that's always nice. So if we look here, we have solve each equation. So 3x squared minus 75 equals 0, so I want to isolate my variable term, moving 75 over to the other side with inverse operations. And now as I simplify, I have 3x squared equals 75. Again, I'm going to isolate my variable by dividing by the coefficient. Divide both sides by the coefficient, and I end up with x squared equals 25. And to get rid of the x squared, because I want to solve for x, I would find the square root of both sides, and then x is going to be equal to the positive or negative 5. Remember, 5 times 5 is 25, and negative 5 times negative 5 is 25. So we have x is equal to plus or minus 5. And that's how we're going to continue to solve these. So as we look at this next example, I want to isolate my variable. So I'm going to add 36 to both sides. And then I end up with m squared equals 36. I'm going to go ahead and do my inverse operations. So in order to get rid of the squared, I'm going to have to find the square root. And of course, helps if I write the problem correctly. And so m is going to be equal to plus or minus 6, because that is going to be the square root of 36. So there's my answer. Hasn't asked me to, but if I wanted to write that as ordered pairs, don't need to worry about that. Never mind. Okay, so moving on. What is the solution of each equation? So here we're going to continue on, and I have isolating my variable. So I'm going to move my 15 over to the other side. And I'm going to have 3x squared. That's going to zero out. That's going to be negative 15. I'm going to divide both sides by the coefficient, and x squared is going to be equal to negative 5. And we have learned in the past that in order to find the square root of both sides, I'm going to have x is equal to the square root of negative 5. And I am unable to find the square root of a negative 5 at this point in time, so that is done. And let's see here, moving on to this next example. Again, isolating the term with the variable first. We're going to move 16 over to the other side. And I'm going to have 0, 0, or should I say 4d squared. Divide both sides by 4. And I'm going to get d squared is equal to 0. And again, the square root of d squared equals the square root of 0. Or d is going to just be equal to 0. One solution, because there's only one root of 0, and that's 0. Okay, as we continue on with our solutions, a little bit choosing a reasonable solution. Okay, so it says this aquarium is designing a new exhibit to showcase tropical fish, and the exhibit will include a tank that is rectangular prism with a length L that is twice the width W. The volume of the tank is going to be 420 feet cubed. And what is the width of the tank to the nearest tenth of a foot? All right, well, when I did this one, I said, okay, volume is length times width times height. And they told us that the width is just W. And then we know the length is twice the width. So I have the width is W, and then the length is going to end up being twice W, 2W. And I've done some substitution. So I know that they gave me volume in the problem, so I can replace volume with 420. That equals length times width times height. And they told me that my height was, how much? Did they say 3 feet? I guess I'm telling you it's 3 feet, huh? So if my height is 3 feet, I know that my height is 3 feet. I know that my width was W. I know that my length was 2W. So I've continued with my substitution. And now I've done some simplification. This 6, I multiplied 2 times 3 is 6. So I divided 6 away to get rid of my numbers over here, which leaves 70 on the left equals W squared. And to get W by itself, I went ahead and did the square root. So the square root of 70 is going to be approximately plus or minus 8.36. and then that is going to be W, and then so my width is going to be 8.36, and I have a positive or negative, right? And it did say reasonable, and it's not reasonable that a negative width, we don't have negative width, so that's not going to be reasonable. So my answer is going to have to be the positive version. So my width would be about 3.4 feet, and I rounded it to 3.4 feet because it said to the nearest tenth of a foot, and the tenth is the first decimal place. So if we go and we work on this next problem, doing the same thing, and we can keep the image of the tank here. So here's going to be my tank, and we know that we have the volume formula, sorry. Volume equals length times width times height. And they've told us that the height's going to be 4 feet. So my height is going to be 4, and the volume is going to be 500, right? And then it says, what is the width of the tank to the nearest tenth of a foot? Well, let's assume that everything else is going to remain the same, right? My length is going to be 2W, and my width is going to be width. So I have 2W times my width. And if I just go ahead and multiply all that out, I got 500 is going to be equal to 8W squared. And now that's a little bit more visible to see that you have to go ahead and divide by the coefficient. And so this is going to carry over here, and that is going to be W squared is equal to this number. Now that is going to be, okay, so I was going to get a calculator, but let's just go ahead and do the division. And 8 goes into 48 6 times. Carry the 2, bring down the 2, 0. 20 goes into, 8 goes into 23 times, so 2 times. It's going to be 16, bring down the 4, bring down the 0, and then that is going to be 40. 8 goes into 45 times, so that's 40. So it looks like W squared is going to be equal to 62.5. And then again to find the square root of both sides, so I can get W by itself. And the square root of 62.5 is, the square root of 62.5 is going to be approximately 7.91 plus or minus. And again, we do not need the negative version of that because that would not be a reasonable length. So the width is going to be equal to approximately 7.9, but they did say round to the nearest tenth, so yeah, width is going to be 7.9 feet. There you go. Going to be the final length of the width. So again, solving, we're looking for the solutions of these equations, and when we're solving for these equations, that solution is when y is going to be equal to 0, and then solving for x, giving us our x-intercepts, roots, zeros, and solutions. So as we work on this, again, a little bit more math-oriented, less graphing, and hopefully it starts to work together as we're learning that new vocabulary word, roots.